pre-training vision transformers with very limited synthesized images. In this presentation we found that ViT can be pre-trained with 1K synthesized images. In the original ViT paper, it was said that pre-training with 300 million images was necessary to achieve a pre-training effect. Then, in the DAT paper, it was possible to pre-train on the 1.28 M order dataset ImageNet 1K by using data augmentation and other techniques. Later on, it was shown that pre-training with a dataset generated from a mathematical formula called FractalDB could also achieve performance comparable to ImageNet 1K, and it was thought that more than 1M images were needed for pre-training ViT. Therefore, we rethink the construction process of FractalDB and propose One-Instance Fractal DB, which consists of one image per category. As a result, we showed that the pre-training effect is comparable to 1K and 21K, GPU hours 78% faster, and the highest accuracy results with limited data in the ViT pre-training. The previous dataset, FractalDB, generated 1000 images offline from a single fractal parameter. Specifically, the 1000 images are generated by variations in the parameters used to generate fractals, rotation, and patch patterns during rendering. We evaluate these offline generated images when using DAT with One-Instance Fractal DB. In the baseline DAT-only case, OFDB has a CIFAR 100 image classification accuracy of 84%. Compared to the baseline, the pre-training accuracy was reduced to 81.6% when training with IFS and DAT. The possible reasons for reduced accuracy are high variation in shape and category. Compared to the baseline, the pre-training accuracy was almost the same for 84.1% of the cases trained using rotation and DAT. Since DAT includes data augmentation of rotation, we can assume that offline image generation with rotation is not necessary. Inspired by our preliminary experiments, we also propose random patch pattern augmentation, in which the patch pattern of fractal points is randomly varied, and random texture augmentation, in which the pattern is randomly varied in grayscale, and apply them to OFDB. We introduce experiment results that comparison with state-of-the-art dataset. OFDB 1K has achieved accuracy comparable to that of a dataset of 1 million. Also, OFDB 1K pre-training performance is better than previous dataset of FractalDB. The next experiment is to scale up the category. We scaled up the categories and compared the pre-training performance with ImageNet to 1K. As the results, OFDB to 1K shows that the pre-training performance improved with increasing number of images, and performance is comparable to the ImageNet to 1K and pre-training time is reduced by 78%. The next experiment is ViT pre-training with small dataset. As the result, OFDB 1K achieves higher accuracy than ViT'(S) SOTA method, IDMM, for limited data, even though it is synthetic data. Thank you for watching.